Hello there, Mr. Sutton here, bringing you these MCAS 2019 solutions. For this problem, we're asked which expression is equivalent to this one. All we have to do here is use the distributive property. So negative 5x has to get multiplied by the negative 6x squared and the positive 1. So negative 5x times negative 6x squared. Negative 5 times negative 6 is 30. X times x squared is x cubed, so that's 30x cubed. And then negative 5x times 1 is just negative 5x. So looking carefully at our answer choices, that would be choice B. For this problem, we're being asked for f of 0, f of 5, and f of 18 for this function up here. So for each of these, we just have to take the number that's inside the f of parentheses and replace x with that number and evaluate. So f of 0, that's going to be 0 times 18 minus 0 instead of x. And 0 times whatever is going to be 0. Next, f of 5, well, we're going to have 5 times 18 minus 5. Well, that's 5 times 13, which is going to be, let's see here, this is no calculator section, so that would be 50 plus 15 if we distribute there, so that would be 65. And then finally, we have f of 18, that's 18 times 18 minus 0, or 18 minus 18 rather, so that's going to be 18 times 0, I was just thinking ahead there. 18 times 0 is 0. So that's all 0 then. On this question, we're trying to figure out the circumference of this circle. So in general, circumference of a circle is going to be c equals 2 pi r, or pi times d. Now in this case, pi times d is going to be more helpful because this third side of the triangle, which they didn't give us but which we can find, is the diameter of the circle as well. So we're going to label this as d, and we're going to go ahead and find it. Then we can plug it into this circumference formula. So to find this diameter, this third side of the right triangle, we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. C squared, that's your side that's across from the right angle, so that's the d side here. So we can write 6 squared plus 8 squared equals d squared. So then square rooting both sides and simplifying a little bit, we need the square root of 36 plus 64. Well, 36 and 64 adds up to 100. Square root of that is 10. So now plugging that in over here, this is really going to be 10 times pi. And that is actually one of the answer choices because this was off the no calculator section. So that's going to be B. For this problem, we want to know if we perform a single transformation on some square, which 3 transformations listed below would result in a congruent figure. So basically, we want to transform this thing without changing the length of the sides or the angles. As luck would have it, most transformations will not change the shape or the size of a shape. Reflections don't change anything, neither do reflections or rotations. I mean, they'll flip, rotate, or move your shape, but they won't change how big it is. The only thing that will change it is if you have a dilation with a scale factor other than 1. So if we want a congruent figure, we really just want anything except a dilation that has a non-1 scale factor. And I mean, a dilation with a scale factor of 1 is kind of silly, but it's a thing. So taking a look at our answer choices, a translation doesn't matter where you're moving it, it's not going to change the shape, so that's fine, or the size. Rotation of any amount is also going to give us a congruent figure. It'll be facing a different way, but we don't care. Dilation with a scale factor of 1 with respect to the origin. So that is not going to change anything. We're just multiplying all the dimensions of the shape by 1. So that gives us a congruent figure. Scale factor of 1.5, on the other hand, will not give us something congruent, and neither will a scale factor of -2. Has a reflection built in there with that negative, but that's not really the deal breaker. It's the 2 that messes us up. So at the end here, A, B, and C are the only ones that give us a congruent figure. On this problem, we're given a system of equations, and we want to solve for an h value that makes this thing true. Well, given that we've already got things nice and lined up, and I've got the h and the c on one side of each equation and the constant on the other side, I can actually just go ahead and add these two equations together. This is using our elimination method. Now, another way you could have done this problem would have been to move the c over to the other side so that you just have h isolated. Then you could set each equation equal to each other, solve for C, go back, plug in, solve for H. But it's really just faster if you add these equations together the way they are. So if we do that, we have 2H. The C's are going to cancel. And on the right side, we have, this will be 4 if we add those together. So if 2H equals 4, that means H must be 2. So that's the value of H that makes this true. On this problem, we want to know which expression is equivalent to this expression. Now, if you look at all of these, it looks like some factoring happened. We probably took out the greatest common factor, so let's just do that up here and see if we can get one of these answer choices. Alternatively, since it's multiple choice, you could distribute in each of these and see what gives you what you started with. It wouldn't take that long. But let's just get our factoring practice in. So I noticed that these are all divisible by a k squared, and also in terms of coefficients, divisible by 2. So 2k squared is what I'm going to factor out. That turns this first term into 2k squared inside of parentheses. And next, this 16k cubed is now an 8k. And 10k squared is now 5. And that's going to match up with answer choice B. On this problem, they want us to graph the solution set of this inequality on the coordinate plane. So to do this, you need to basically pretend it's a normal line and then make a few adjustments. So in thinking about this in terms of y equals mx plus b, we have a slope of 1, because this is 1x. This minus 4 means we have a y-intercept of negative 4. So that's the basic mechanics of how we're going to graph this. Put a dot on the y-axis, use the slope to get another dot, draw a line through them. But now since this is an inequality, we have to think about solid versus dashed lines and also which direction we're shading, above or below the line. Solid versus dashed, we see there's an equals on this inequality, so this is going to be a solid dots and solid lines kind of situation. And we also notice that we've got greater than as the inequality, so that means we're shading above because it's y greater than, so the y values are greater than this line here. So shade above. So now solid dot on negative 4 for the y-intercept, that's down here. Slope of 1 means we're going up 1 over 1, put another dot. Draw a line through those, solid line. And we're shading above, so everything above here. And if you weren't really sure where to shade, you could plug in a point like 0, 0 to see if it makes this inequality true or not. If you plug in 0, you would have ended up with 0 greater than negative 4, which is a true statement, so we would shade the side that had 0, 0 in it. For this problem, we're given this W line here, and we want to know which equation represents a line perpendicular to this line. So the only thing about a perpendicular line that you really need to know to do this problem is that the slope of a perpendicular line will have the opposite reciprocal slope of the original line. So you need to know the slope of the original, and then you can just flip and negate the coefficient on x to get a perpendicular line. Original slope, because this is in y equals mx plus b form, is going to be 5, because 5x there, that's the m value. And now the opposite reciprocal, we have to make this 1 over 5 and then negate it. So this ends up being negative 1 over 5 for the perpendicular slope. Let's look at our solutions now, our multiple choice. We only have one answer choice with a negative 1/5 as the slope. That's choice A, so that's our answer. On this multi-part problem, we have a line and a parabola, and the equation of both are given in this table. For the first part here, they want to know the y value of the line when x equals negative 4. All we have to do is just plug negative 4 in for x in the line here. So we write y equals negative 3 times negative 4 plus 5. Well, this is just going to be 12 plus 5, which is going to be 17. On part B of this problem, they want to know the value of y for the parabola when x equals negative 4. So we'll plug negative 4 into the parabola equation here. We write y equals negative parentheses negative 4 squared plus 2 times negative 4 plus 1. So just be careful with your PEMDAS and your simplifying. We're going to take care of this negative 4 squared first. This is going to be 16, but we have a negative out front, so this is negative 16. Then we've got minus 8, and then finally plus 1. So this is going to be negative 24 plus 1 is negative 23. For this part of the problem, they're telling us the line and parabola intersect at 2 points. They're not actually asking what they are, but they are asking is if the distance they're telling us is represented by this expression, they want us to simplify this to get the distance in units between the 2 points. So all we have to do is just use PEMDAS and simplify this thing. Let's go one step at a time. So we're going to do the inside of the parentheses first because of PEMDAS, the P. So this is 3 squared and negative 9 in a parentheses being squared. So this is going to be the square root of 9 plus 81, which is going to be the square root of 90. Now we have to simplify the radical, so I can split this up into square root of 9 times square root of 10. Square root of 9 is really 3, so this is just 3 root 10. For part D, we're about to receive a lesson on how basic arithmetic can be made extremely painful. We're being asked basically to simplify this whole expression. The backstory on this is that this is the area of the region on the coordinate plane enclosed by the parabola on the line, but we don't really need to know all that. We just need to simplify this thing. So using PEMDAS again. Now one way you could do this is to simplify this whole parentheses and then do the rest of this stuff. But it actually might be a little faster if we just distribute this negative just to take care of that right away. So that's what I did anyway. So I just rewrote all these first 3 terms with no change whatsoever. But now I'm going to distribute this negative. So I now have positive 1 cubed over 3 minus 5 times 1 squared over 2 plus 4 times 1. So now we have one less nested parentheses to worry about. All right, now that I don't have to worry about parentheses, exponents is next on my checklist for PEMDAS. So let's see here. We've got 4 cubed, which is 64, so negative 64 over 3. For this next thing, I've got 5 times, this is going to be 16 now, over 2. We'll just leave this the way it is for now. And then this next one, 1 cubed is really 1. For this next one, 1 squared is really 1. So this is 5 times 1, or just 5 over 2. And we've got 4 times 1 still. So we've taken care of all the exponents. Now we're going to take care of multiplying and dividing. They're really the same step. You basically have to do the terms first before you can add or subtract anything together. So let's see, negative 64 over 3. I'm going to leave that the way it is because I have a feeling I'm going to have to do some fraction math later on. And let's see, 5 times 16, I'll take care of that. That's going to be 80. So 80 over 2. And then 4 times 4 is 16, so we have minus 16. 1/3 I'll leave. Negative 5/2 I'll leave. 4 times 1 is really 4. Great. Okay, let me combine like fractions at this point. So I've got negative 64 over 3 and 1 over 3. That adds up to negative 63 over 3 if I combine those fractions with the same denominator. And then 80 over 2 and 5 over 2, negative 5 over 2. That combines to give us positive 75 over 2. And then finally, we have negative 16 and positive 4 combines to give us negative 12. I can clean up this negative 63 over 3 a little bit. That's really, if I divide, that's going to be negative 21. And let's see here, negative 21 minus a 12, I'll take care of those. That adds up to negative 33. And finally, I have to combine these together. Negative 33, I can rewrite that with a 2 in the denominator as negative 66 over 2 if I multiply by 2 over 2. Negative 66 over 2 plus 75 over 2, that's going to be 9 over 2. And that's as simplified as it's going to get. You could turn it into 4 1/2, but you don't need to. On this problem, we have a waiter recording the amount of money he earns in tips each weekday in this table. Which statement about the data is true? So they're asking about the median, the range, the mode, the mean, basically pretty much everything you could possibly want to ask about for a data set. So we're going to find all of those things, put them in a table, and then we'll be able to compare them. So this is kind of a longer multiple choice question. We're in it for the long haul here. So let me set up a table. We've got week 1, week 2, and let's find the mean first. So for week 1, mean in general is going to be the sum of all the data items divided by the number of items. So in this case, adding all of this money together, let's see, we've got a 25, and that easily combines with 75. Now, this was a no calculator question. So 25 and 75 is 100. We've got 144 plus another 48. That's going to be, let's see, 192 plus 63. Let's see, that would be 195 plus 60. That would be 255, and there's 5 days. So 255 over 5. Now 250 over 5, that would give us 50. So 255 over 5 is 51. Great. All right, well, next up, let's do week 2. So we've got 35 and 35. Well, that's pretty easy to add together. That's going to be 70. 48 and 62, that's going to be 110. 110 and the original 70 here is 180. 180 and 75 adds up to 255, which divided by 5, again, is going to be 51. Nice. Okay, so these are actually the same thing. Let's keep going here. Let's do median. Now, when you're doing median, that's when you line up all the data items from least to greatest and pick the middle value. Now, the nice thing about this problem is if you actually look at this table, it turns out that he earned progressively more money as the week went on. So these data items actually are already sorted from smallest to greatest. That was so nice of them. So the median for week 1 is going to be 48. The median for week 2 is also 48. Well, that was easy. Okay, let's do mode. This is the data item that appears the most. Week 1 is a little bit tricky because they're all unique numbers, so there is no mode for week 1. Week 2, 35 appears more than any other number, so 35 it is. And then the range, that's the difference between smallest and greatest. Now, again, it's helpful that these are already sorted from smallest to greatest. They just happen to be that way. So 75 minus 25 gives us a range of 50 for week 1. 75 minus 35 gives us a range of $40 for week 2. And now we look at all of our answer choices. So choice A, median and range for week 1 are equal to the ones for week 2. Well, the medians are the same, the ranges are not, so it's not A. And then let's see here, choice B, median and mode are equal. Well, there is no mode at all for week 1, so that's garbage. C, mean and median are equal. That is true. And then let's just look at D, mean and range are equal. Nope, we already said the ranges are different. So the mean and median are the same, giving us answer choice C. For this problem, we want to know the coordinates of the midpoint of the line segment KL. So basically, you just need to use the midpoint formula here. So here is that midpoint formula. You basically have to average the x values together and also average the y values together. So in this case, we're going to have negative 3 plus 2 over 2 for the x value, and we're going to have 5 plus negative 3 over 2 for the y value. And we're going to have to simplify this to match one of the answer choices. So for the x value, we have negative 1 over 2, which we can't really reduce anymore. For the y value, we've got 2 over 2, which we can reduce to 1. So negative 1/2 comma 1, that's choice B. For this multi-part problem, we have Shayla and Carlos with a bag that has some marbles in it, 5 green, 5 red, and 10 yellow, and they're all the same shape and size. For part A, Shayla is selecting 2 of these randomly, and she will not return the first marble to the bag before picking another one. So that's an important piece of information right there. We want an expression with the probability that Shayla will select 2 red marbles. So the key here is recognizing since we have 2 events going on, these events are dependent on each other because whatever Shayla picks the first time around is going to impact her chances for what she'll get the second time around, since she is not putting the marble back. So we would say these are dependent events. The second event is dependent on the outcome of the first one. So we want to find the probability of a red marble followed by another red marble. Well, the probability of the first red marble, since there are 5 marbles that are red and 20 overall, would be 5 over 20. Now, to figure out the probability of this and another event, a compound event, we have to multiply the 2 probabilities together. So what's the probability of another red marble? Well, since Shayla's already picked a red marble and she's not putting it back, that means there's 4 red marbles left. overall there are 19 marbles left. So 4 over 19 is what we have to multiply by. And we don't actually have to multiply or reduce because we just had to get the expression, and the answer choice is going to be this. So it's going to be, let's see here, we got 5 over 20 for all of these. It's just 4 over 19 it's going to be different, and that's going to be choice A. For this next problem, part B, Carlos will select 2 marbles from his bag. He will not return the first marble to the bag before selecting a second marble. The first marble Carlos selects will not be yellow. What's the probability, and here's where they're actually asking a question, what is the probability that the second marble he selects will be yellow? Answer as a fraction. Okay, so this one's a little bit tricky. They're not asking for the probability that Carlos picks a non-yellow marble followed by a yellow marble. That's not exactly how the question is worded. What they're saying is, okay, Carlos has already picked a marble. Given the marbles that are left, kind of starting with that as our reference point, what's the probability that this marble he picks will be yellow? So we have to take things as they're already given to us. We're already given that Carlos has picked a marble that's not yellow. So we're looking for a conditional probability. We are looking for the probability of yellow given that not yellow has already been picked. Well, how many marbles are yellow? 10 of them, and 10 are not yellow. So that means that if he's already picked one that's not yellow, then we have 10 yellow marbles still available to pick from. And we have overall 19 marbles left. So then our probability would be 10 over 19, and that's it. On this problem, we want the solutions to this quadratic equation. Since we've already got it all zeroed out and it looks factorable, let's try factoring it. So we need 2 numbers that multiply to 12 and add up to 7. That would be positive 3 and positive 4. So let me rewrite this as x plus 3 times x plus 4 equals 0. And now if one of these equals 0, then the whole thing equals 0. Since we have a product, we can use the zero product property. So this equation is going to be true if x equals negative 3, because that would make this first parenthesis 0 and 0 out the whole equation. It's also true if x equals negative 4. That would 0 out this second factor. So those are our answers, negative 3 and negative 4, and that is choice A. On this multi-part problem, we have a double bar graph showing the amount of time an athlete spends on aerobic versus strength training over the course of a week. And for the first part, we want to know on what day did the athlete spend the longest total amount of time training. Explain how you got your answer. So we already have one graphic representation of this data, but I think it would be helpful if we also made a table of what these exact values are so that we have some numbers to work with and we don't have to keep looking at this graph. All right, so let me set up a chart. I'm going to have a column for aerobic training, strength time, and total time. And this total column is going to be important on part A because we want to know what total was the biggest. And in my rows, I've got the days of the week. So for Monday, I had 10, minutes. Yep, 10 minutes with aerobic training, and this looks like 20 for strength. So that gives me an overall total of 30. I'll just add it up as we go. For Tuesday, we had 60, and then 10, and then total of 70. Wednesday aerobic was 20, strength was 15, adds up to 35. So far Tuesday was the best day. Wednesday, or rather Thursday, we have 50 for aerobic, 30 for strength. So that's 80 total. Ooh, that's even better than Tuesday. How about Friday? We got 40 for aerobic, and strength training was 45, so that adds up to 85. So this is one where you didn't want to just kind of eyeball it and say, it looks like this one's bigger, because Thursday and Friday were actually pretty close, but it looks like Friday has the longest amount of time. So Friday it is for part A. For part B on this question, we want the median total number of minutes the athlete spent training each day. So this is where it helps if you've already got this chart created from part A where you've already added up the totals for each day. So now to find the median, we're going to write these numbers in order from smallest to greatest and then pick the middle value. So our lowest value was this Monday amount, 30, followed by 35 on Wednesday, and then 70 on Tuesday was the next biggest, followed by 80 and 85. Now the middle value here is 70, and that was Tuesday that happened. So that was our median amount then, 70 minutes. For part C, we want to know the percent of the total number of minutes the athlete was spent on strength training. So we already have totals for each individual day. We have not yet made a total for each type of training. So I'm going to add another row to my table now that I see that I need it. This is going to be the overall total for each minutes. So adding up all the totals for the aerobic training now, we've got, let's see, 10 plus 60 is 70, plus 20 is 90. We've got another 90 here, so that's 180 minutes total spent on aerobic training. For strength training, I've got, let's see, 20, 10, 30, that's 60, plus another 60 if you add the 15 and the 45 together. Doing some quick mental math, that's 120. And then the overall total, we can just do 180 plus 120, or you can add these together. They should add up to the same thing, which is 300. So to figure out the actual percent on strength training, I'm going to set up a proportion. So I've got 120 is the part. The whole is 300, so 120 over 300. And I'm going to set that equal to, we'll say, x, or whatever your favorite variable is, over 100. This is the percentage fraction here. So if I cross-multiply and solve this proportion, I'll figure out what percentage 120 is of 300. So I can write 300x equals, and then 120 times 100, that's going to be, let's see, 1, 2 with a 1 with 3 zeros after it, so 12,000. Dividing both sides by 300, I'm going to cancel out 2 of those zeros and divide 120 by 3 essentially. So that's going to be 40% then that we spent strength training. For this last problem part, they want us to determine whether the sum of the mean number of minutes spent on aerobic training and the mean number on strength training is equal to the mean total number of minutes spent training. All right, so it helps if you've got this last row that we created in part C. So mean number of minutes in general, that's the total number of minutes divided by the number of days, I guess, would be the number of data items here. So for mean number with aerobic, we've got 180 over 5 because of 5 days. And that's going to be, let's see, 36 if we reduce that. And then for the strength mean, we've got 120 over 5, which is going to be, if we do long or short division, whichever, ends up being 24. And 24 and 36, that's going to add up to 60. All right, so now we're going to find the mean number of minutes total and see if that's also 60. So 300 divided by 5, yep, that's also 60. So the conclusion then is that yes, these quantities are equal. On this problem, we have a rectangular garden that's 16 1/4 feet wide and 11 3/4 feet long, covering it with soil. Bag of soil covers 20 square feet. We want the closest number of bags of soil needed to cover the garden. This is a no calculator question, so you had to round off and estimate a little bit here. But how much to round off? Well, in general, you don't want to go, if you're looking for the closest number of bags, you don't want to go too much further than just rounding to the nearest whole number. Let's do that and see what happens. So 16 1/4, we'll call that 16. 11 3/4, we'll call that 12. So estimating the total area needed would be about 16 times 12. And if we just do a little distributive property here, we've got, let's see here, 10 times 12, that would be 120. 6 times 12 is 72. 120 plus 72 is 192. Or you could multiply it out by hand. It's a 2 by 2. It's not too bad. So that's 192 roughly that we need for square footage. Now, if one bag of soil covers 20 square feet, and we want to know how many bags of soil we need, we essentially need to estimate 192 divided by 20. But 192 and 20, that doesn't really go evenly. So we're going to round this up to 200. If we're trying to be safe about the bags of soil needed, we can't just buy a part of a bag of soil, right? If it's a fraction of a bag that we need, we have to buy the whole bag. So let's call this 200 and divide that by 20. And that tells us then that we need 10 bags of soil. So choice D. On this problem, they're telling us that two of these triangles are similar. They want us to select the similar ones. So the key on this, since we only have angles, and I mean we can't really judge this by, oh, they're the same shape and things aren't necessarily drawn to scale. We know that similar triangles have the same angles. That is the key on this. So we have to basically just pick the two triangles that have the same angles. Now, of course, they didn't give us all the angles, so you have to find the third angle in each of these triangles. Well, let's just start with this one here. So let's see here. We've already got 74 and 68. That's a total of 142 degrees. Now, the whole triangle has 180 in it. So to get to 180, if you've already got 142, you need another 38 degrees. And then over here, 45 and 68, that's going to be 113. We need another 67 to get to 180 there. Down here, 45 and 74. Let's see, that's going to be 119. So that's 61 degrees you need there. And over here, 38 and 68, that's going to be 106 to start with. So you have 74 degrees that you're missing. Looking at our angles now, let's see, 38, 68, 74, does that match any of these? It matches this one down here. So the upper left and the lower right then are going to be the triangles that are similar. For this next part of the problem, they basically just want us to finish this similarity statement here. So they're saying triangle EFG is similar to triangle, and I mean obviously you need an X and a Y and a Z over here, but the order is important. The key here is that you write the letters in the same order as the angles they're equal to. So first angle on the first part of the statement was angle E. That's this angle here. That's the mystery angle. We've already accounted for 68 and 74 degrees in the second triangle here. So mystery angle, which if you look back on this last part of the problem was 38. So 38 degrees here, 38 degrees here. Angles E and Z are corresponding angles. So we're going to write Z as our first angle. Next angle they give us was F. F is 68 degrees. X is 68 degrees. So we're going to write X next. And then that just leaves Y as the odd one out here. It's the only one left. And it does match G, which is 74 degrees. So Z, X, Y. On this problem, we want to know which of these expressions is equivalent to this quadratic here. Basically, just need to factor. So we're looking for factors of negative 84 that add up to 5. So let's see here. We've got, well, we can look at our answer choices here. I mean, they kind of gave these to us. 6 times 14, that does multiply to give you 84, but it does not add up to 5 in any way, shape, or form. And now if you look here at 7 and negative 12, well, positive 7, negative 12, that would add up to negative 5. How about negative 7 and positive 12? Yep, that would do the trick. Multiplies to give you negative 84, adds up to positive 5. There it is, choice D. On this problem, we're given this triangle, and we want to graph a dilation of this thing. Let's see, we want to dilate it by 1/2, they said, with respect to the origin. So basically, figure out how far away you are from the origin in each direction, and multiply that by 1/2 to get a new point. So let's start with point K and see what that turns into. That's 6 away from the origin horizontally and 2 away vertically. So we're going to move it in 3 away and 2 down here. So that's going to be K prime, I guess. There's the image of K. And now let's see, L, that's 6 away in the other direction and 2 down. So we want to go right 3. And it was down 4 originally, so we want to be down 2, I should say there. Yep, there we go. And then M, that's 2 to the right and 6 up. So we want to instead go 1 to the right and only 3 up, multiplying each dimension by 2, or 1/2 rather. And then just connect the dots. There we go. On this problem, we're just answering true, false to these statements about rational and irrational numbers. So this is where it helps if you know your properties of number systems. By rational numbers, by the way, we mean anything that can be expressed as a fraction. Irrational, well, cannot be expressed as a fraction and includes numbers like pi. So, first statement, the sum of 2 rational numbers is rational. Well, there's lots of examples we can find where this is true. I mean, 1/2 plus 1/2 is 2/2 or 1, and there's so many others. But you can always add two rational numbers together. If you have two numbers that aren't fractions, I mean, obviously you can add those. Two numbers that are fractions, you can just get a common denominator and add them that way. So that, and you'll get another fraction. So that's going to be a true statement then. Product of two rational numbers is irrational. Well, think about multiplying two fractions together. You just get another fraction. So that's a false statement. That's not irrational because you can express the product as a fraction. So that's false. And then the sum of a rational number and an irrational number is rational. Well, this is an easy one to find a counterexample for. I mean, let's take, for example, just 1 plus pi. That's going to be like 4.14 and a whole bunch of decimals that go forever and don't repeat. So this is also a false statement. You add a rational and an irrational together, you're going to get something irrational because you've already got that crazy decimal that you can't really get rid of just by adding stuff to. On this part of the problem, we just need to drag and drop one of these phrases into the box here to complete the sentence. So first one, sum of pi over 2 and pi over 2 is rational or irrational. Well, this would be 2 pi over 2, which is just pi, and that is an irrational number, or at least believed to be. So we'll put irrational in there. And then product of 1/2 and pi is, well, that's pi over 2, which is also irrational. So there we are. On this problem, we need to solve this inequality. Don't have to graph it, just need the correct solution statement here. So first step, let's subtract 2 from both sides. That does not reverse the direction of the inequality. So we have negative 4y greater than 12. Now we have to divide both sides by negative 4 to isolate y. Now that is going to reverse the direction of the inequality. So this is going to end up being y less than negative 3. And then that is going to end up being choice B. For this problem, we want to know the measure of side t here, given that we have 60 degrees up here and 12 here. Now, before you start going into your SOHCAHTOA dance on this one, this is a special right triangle, so you could use something a little more low-tech. And this also, the benefit of special right triangles is you don't need a calculator. Looking at the answer choices, you could have an answer in radical form. So what kind of special right triangle is this? We've got a 90, we've got a 60, there's 30 degrees left over here. This is a 30, 60, 90, whose sides are in the ratio s, s radical 3, and 2s. I'm going to go ahead now and label my triangle with each of these three sides. The s side is always across from 30 degrees. Here's your 30-degree angle, so s is over here. And it looks like s is not really going to be involved in the problem, at least this side we don't really care about, but we'll put it there. S root 3 is across from 60 degrees, so that actually corresponds with the t side that we're looking for. And then 2s, that is always across from the right angle, so that corresponds with this 12 side. So in order to figure out t, we need to know s, and in order to do that, we need to solve an equation with 2s and 12 being equal to each other. So if 2s and 12 are the same thing, that means that magical s we're looking for is 6. So that means that t, which is really s radical 3, turns out to be 6 radical 3, which is answer choice C. On this problem, which is the first of the calculator section, we want to know the volume of this pyramid. So volume for a pyramid on your reference sheet, it says 1/3 base times height, base area times height. Now the base area, since this is a square pyramid, the base is a square, and the base is just going to have an area of 6 squared. So we're going to have 6 squared, we're going to have a height, an absolute height of 4. We're not looking for the slant height here, we're looking for the height. So we have 1/3 6 squared times 4 for the height. And you could use a calculator. You don't really need one, though, because we've got 6 squared, which is 36. A third of that is really 12. 12 times 4 is 48. So that's 48 cubic inches, gives us choice A. On this problem, we have a travel agent surveying people in 2 age groups, blah, 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 two-way table. Okay, so we just need to complete the blanks in this two-way table. So the idea here is that each row adds up to a total, each column adds up to a total. So if I want to find out the missing part of this row, well, what would I have to add to 10 in order to get the total of 50? Well, that would be 40. And now I can go this direction here. What would I have to add to 40 in order to get 60? Well, that would be 20. And then what do I have to add to 20 to get the 50 over here? Alternatively, what do I have to add to 10 to get 40? Both cases, it's the same answer, 30. For this one, we want to know which graph does not represent y as a function of x. So the key word here is function. If something's a function, it's got to pass the vertical line test. Now looking at all these, here we just have a line, a parabola, an absolute value. These can all be expressed as y equals some function of x. Y equals mx plus b, y equals something with an x squared, y equals something with absolute value of x. This last one, choice D, this is going to fail the vertical line test. There are multiple places where the same input, the same x value, gives us two different y values, two different outputs. Since D is the only one that fails the vertical line test, we would say D does not represent y as a function of x. It's not a function. For this problem, we're given this square on the coordinate plane, and they're going to reflect it over the y-axis. They want us to graph the image of that square after the reflection. Okay, so let's just start with E and start reflecting over the y-axis. So we've got E moving over here, F is going to move right here, G is going to move 3 to the left of the y-axis, so will H, and connect the dots. For this problem, we've got a parallelogram on the coordinate plane. We want its perimeter, which basically means we need to add up the sides. Now, there's a few ways to do this problem. The key here is recognizing that since it's a parallelogram, we know that two pairs of opposite sides are going to be congruent. In other words, if I know how long this side is here, I can just multiply it by 2, and that gives me this other side. Same thing with these short sides. So really, I just have to find this side and multiply those each by 2 and add it all together. Now, here's the other way that you could do things a little differently other than, finding all 4 sides. You could use the distance formula to figure out each length here. But you don't really need to do all that work. You can just use regular Pythagorean theorem if you draw a couple triangles in here. So for example, let me draw a triangle over here, and let me use this to find the length of this short side of the parallelogram. So this triangle has a base of 3 and a height of 4. And if I want to find the third side, the hypotenuse, I could do the square root of 3 squared plus 4 squared and use Pythagorean theorem. However, you might also recognize this is a 3, 4, 5 triangle and not have to do the Pythagorean theorem. So that takes care of this side. We know that this side is 5, this other side over here also 5. Now we need this long side. Drawing another triangle in there, I see that I have a base of how much? Well, to go from -3 to 9, that's a distance of 12. We have a height of 5, and you could use Pythagorean theorem, or you might recognize this is a 5, 12, 13 right triangle. That's another one of the common ones. And again, not have to use Pythagorean theorem if you recognize that. So perimeter, we've got 2 times this 5 side plus 2 times this 13 side. That's going to be 10 plus 26 is 36. So choice B. For this problem, we're given a sphere and we want to know the volume, at least to the nearest whole number. So in general, we know the volume of a sphere is going to be 4/3 pi r cubed. That's a volume formula we have for spheres. In this one, we just need to find the radius and plug it in. Well, what they've given us here, you got to be careful. This is the diameter, 13 inches across. So if I'm plugging that in, I really want to take 13 divided by 2 to get the radius. And that's going to be my r value. So then I'll have 4/3 pi times 13 halves cubed. And now I need to put this in the calculator. So entering this in the calculator, so I used alpha y equals and n over d, fancy fraction, to get the 4/3 and the 13 halves. fancy formatting. If you didn't want to do that, you could have done a parentheses with division inside, and that would also work. So at the end of the day, pressing enter, we get about 1150 for this one, cubic inches. So that's going to be choice B. For this problem, I've got a table of values for the linear function f of x and an explicit g of x function. I just want to compare these and see which one has a greater rate of change and a greater y-intercept. Let me start by writing f of x, which can be put in mx plus b form since it is linear. For the m value, I need rise over run, so that would be y2 minus y1, so 90 minus 120, over x2 minus x1, 20 minus 0. That's going to be negative 30 over 20, which I can reduce to negative 3/2. And now for the y-intercept, that's going to be wherever x equals 0. And it looks like that's going to be, where x equals 0, so that's going to be 120 for the y-intercept for the b value. So I can write this as then f of x equals negative 3/2 x plus 120. Okay, so at this point, let me compare the rates of change. So for g, I have a rate of change of 10. F of x is negative 3/2. And let's see here. It looks like negative 3/2 is less than 10. 10's bigger, so g of x has the greater rate of change. Now comparing the y-intercepts, we've got f of x, which is 120, g of x, which is 40. 120 is greater than 40, so we can say that f of x has the greater y-intercept. For this problem, we have a factory worker loading some boxes onto a cart. Each box has the same weight, and this expression represents the total weight, given n boxes. Based on the expression, what is the weight in pounds of the cart? All right, so we basically have to figure out where each component of the total weight ended up. We have the weight from the boxes, each of which weighs the same thing, and we have the weight of the cart. Well, if each of the boxes weighs the same thing and there's n of them, then this 10n expression most likely represents the weight of the boxes. Each box then would be 10 pounds. That means that this kind of fixed cost of 25, that it's going to be 25 no matter how many boxes you have, is going to have to be the cart. So each box must weigh 10 pounds. The cart then must weigh the 25 pounds that you see here. For this problem, we have triangle PQR on the graph here. And part A, student reflects this triangle over the x-axis to create another triangle, EFG. We want the coordinates of vertex E. So I'm just going to figure out where E went, and I'm not going to worry about the rest of the triangle because that's all they care about here. If I'm reflecting over the x-axis, then E, which is the image of P, the reflected part of P, is going to have to end up right about here. And now I just want that point right there. This is -1, -1. On this part of the problem, a student performs a different transformation on our triangle to create JKL. Coordinates of vertex K, they're telling us, are 4, 1. What could be the single transformation the student performed? I think it's easier if you put 4, 1 on the graph and see what happened to the original point. So here is 4, 1 right there. And now the key here is that K, based on how these triangles are arranged here, K is going to be the image of point Q from the original triangle. So what happened to Q to get it over here? And they said what could be the single transformation. So there's definitely a lot of different options here. You could use a translation of 8 to the right. You could also just simply reflect Q over the y-axis. I think that would be the most believable one. So that's what I'm going to go with, but a translation also would have done the job. For this part of the problem, they want us to describe a single transformation we could perform so that UVW, the image of PQR, is similar but not congruent to the original. Well, similar but not congruent, that's the key words there. That means that we need to have the same angles but different side lengths. The only kind of transformation that ever gives you different side lengths is a dilation with a scale factor other than 1. So for example, you could have a dilation about Q, because we have to specify where the center of this thing is, a dilation about Q with a scale of 2, and that would do the job. For this last part of the problem, we want to know the coordinates of vertex W, which is from part C. It's this transformed part of PQR. So we want vertex W after performing the transformation described in part C. So this is kind of open-ended because you have to go back to what you said in part C and figure out where W, which is the image of R, is going to end up. So recall from part C, I said, and you could have said something different, but I chose a dilation about Q with a scale of 2. So that's what I need to do now to coordinate R to see where W ends up. So W, again, that's the image of R, and if I'm dilating about Q with a scale of 2, I'm going twice as far away from Q. So R is moving up here. That's going to be W up there. And what point is that? That's going to be -4, 7. So that's an answer based off of what we put for part C. This would be the answer. If you had something different for part C, then you would have a different answer here. On this problem, we have Marvin solving this equation, and he actually did all the work for you. You just need to explain what he did on each step. And there were some drag and drop sort of deals you could put in here, but we're going to just do fill in the blank. So this first step, we went from 4 parentheses x plus 5 to 4x plus 20. Well, clearly Marvin multiplied 4 by each of these using the distributive property. Next, we got a plus 20, and now we don't. What happened to it? Oh, we subtracted 20 from both sides to turn 88 into 68. So subtract 20 from both sides. And then finally, 4x equals 68 turned into x equals 17. Well, if you want to get rid of times 4, you have to divide by 4, and we have to divide both sides by 4. For this problem, they're telling us each exterior angle of a regular polygon has a measure of 30. What's the total number of sides of the polygon? The key here is realizing that every polygon has exactly 360 degrees for exterior angles. Interior is a little tricky. You have to use like 180 times n minus 2, but exterior is always 360. So if you want to know the number of sides, you just have to take 360 and divide it by one of these exterior angles. 360 divided by 30 then is going to be 12. So this is a 12-sided figure. That would be, what, a dodecagon? Well, it doesn't really matter because 12 is one of the answer choices, so choice C. For this problem, we have a map wherein an inch equals 0.75 miles. They're telling us the distance between a museum and a library is 2 inches. What's the actual distance between the museum and the library? So we're going to set up a proportion. For one fraction, I've got 1 inch over 0.75 miles. And I'm going to set up another fraction with inches over miles. Now the key here is that I've got 2 inches on the map between a museum and a library. I want to know how many miles. So I'm going to write this as 2 inches over d miles. Now all I have to do is solve this proportion, and I'll figure out what the real distance is. So cross multiplying, we've got 1d on one side, and 2 times 0.75. You could use a calculator, but you don't necessarily need to. That's going to be 1.5. So then d equals 1.5 miles. For this next part of the problem, actual distance between the library and bus stop is 3 miles. What's the distance in inches on the map? So setting up our proportion again, 1 inch over 0.7 miles. We can now say that that equals d inches over 3 miles, or you could use a different variable so you avoid confusion with part A. Cross multiplying, we've got 0.75 equals 3. And you could use a calculator here. Another way of doing this is realizing that this is really 3/4 times d. If we multiply by 4/3, the 3's are going to cancel, and we just end up with d equals 4 inches. For this problem, we're given 2 triangles that are similar to each other, and we want to know the length of side XZ, this side right here with the question mark. Well, this is a little bit tricky because we don't actually know the lengths of this first triangle here. We know how they relate to each other. We have 2 lengths on this triangle, but without any kind of angles, we can't really use those to find our third side. So how do we do this? Well, first we need to figure out the value of k, and then we can set up a proportion to find this missing side. Before I can do that, though, I need to find k. I'm going to use proportions to solve for k. I know that k plus 3 over k plus 5, since these triangles are similar, this is going to be the same ratio as 36 over 44. And how do I know those are the same? Well, I mean, if you look at the shapes, it looks like that's the same side. But if you didn't believe the scale, LM, those are the first two letters of this first triangle. XY, those are the first two letters of the other triangle. So the position in the name of the triangle tells us what corresponds to what. All right, to make my life a little easier, I'm going to reduce 36 over 44. I'm going to reduce that by 4, so that's really 9/11ths. And I'll have my original fraction equaling that. This will make it a little bit easier to cross multiply now. So doing that, I'll go this way first. So I've got 11k plus 33 on one side, and this is going to equal 9 times k plus 5, so 9k plus 45. Subtracting 9k over here, that gives me 2k on the left. Subtracting 33 to get it over on the right, that's going to be 12 over there. So then k has a value of 6. Okay, so let's use that now in order to set up a proportion and solve for my missing side. So I can say that 6, which is our k value, over 6 plus 3, this value here, aka 9, that's going to be the same ratio as this xz distance over 36. And now cross multiplying in this situation, this is really 9, so 9xz is going to equal 6 times 36, which it's up to you whether you actually want to multiply this out. You have a calculator available, so you can. It comes out to 216. But if you didn't multiply it out, if you just left it as 6 times 36, it actually might have been easier then just to divide the 36 by the 9 here. But if you waited, 216 divided by 9 with or without a calculator ends up being 24. So 24 then ends up being choice C. On this problem, at the beginning of the year, Samantha deposits $1,000 into a savings account with 2.5% interest, which these days is actually a pretty good interest rate. She doesn't deposit any money or withdraw money for a year. Great. Part A, interest rate expressed as a decimal. This is basically, do you know how to turn an interest rate into a decimal? All we have to do is move the decimal 2 to the left. 2.5% means percent, means divided by 100 literally. So you're just dividing this by 100, and that's going to give you 0.025. For the next part of this problem, they're giving us a formula that we can use to calculate the amount of money, including interest, in an account over time for a deposit of $1,000. So this is based off of an exponential formula that you learn in pre-calculus or earlier. And just looking at the parts of this, A is the amount of money, like the answer for most of these problems. R is your interest rate expressed as a decimal, so that will come in handy, what you just did. And then T is how long you're leaving the money in there. N is the number of times interest is compounded in 1 year. Okay, what is the amount of money in dollars in Samantha's account at the end of 1 year if interest is compounded annually, once a year? This is essentially just a plug-it-in kind of question. So we can say our A value equals $1,000 times 1, in a parentheses, plus, now the R value, they said that's the interest rate is a decimal, so that's going to be 0.025. And then number of times a year that we're compounding, they said, let's see, compounded annually once per year, so N is 1. N gets used again up here in the exponent, still 1. Time, well, we're leaving this in here for 1 year, so that's also a 1 up there. And you could use a calculator, but at the end of the day, this is just 1,000 times 1.025. We're just going to move the decimal over 3, so that's going to be 1,025. Again, you could have used a calculator, though. For Part C, the situation has changed a bit. Still a $1,000 deposit. This time, though, Samantha's new savings account pays 3% interest. Look at Samantha upgrading. And this is compounded semi-annually, twice per year. She does not deposit money or withdraw it for a year and a half. So a lot of parameters have changed here. We want an equation that can be used to determine how much money we have at the end of 1.5 years. So you don't actually want to plug in just yet for this part. You just want to write the expression out with everything plugged in. So we can say that our amount now equals, still have the $1,000 times parentheses 1 plus. But now for our fraction there, our interest rate is going to be 0.03. And now denominator, number of times we're compounding, they said we're compounding semi-annually, twice per year. So that's going to be a 2 down there. And also gets used up here, so that's another 2. And then the time period, we can write 1 1/2, or you can write 1.5. Either way, that's the expression that will give us the amount of money at the end of that time. For this last part, they want us to use the equation we wrote in Part C, which is this equation again, to determine how much money Samantha's new savings account has at the end of 1.5 years. Basically, you just have to plug this into your calculator. So let's do that. All right, so here we go. We've got $1,000, and I'll open a parentheses, 1 plus. Let me do alpha y equals to get my fancy fraction. Or actually, if you don't want to do it that way, another way you could do it, just to get rid of that and show you an alternate way, you could open another parentheses. You could do 0.03 divided by 2, close the parentheses, close another parentheses. This second parentheses now is the actual parentheses we're showing here. And then we have to do exponent, and then 2 times 1.5. Now, if you have an older calculator, you might need a parentheses around the 2 times 1.5. But if you have a superscript on your calculator, it will do that grouping for you. And then pressing enter comes out to about $1,045.68. For this problem, we have a storage rack with 2 wires supporting the sides. Blah, 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 blah. What's the length of each wire? So we're given 6 feet, 12 feet. These are right triangles, so we use Pythagorean theorem. A squared plus b squared equals c squared. So we can write here 6 squared plus 12 squared, or vice versa, equals this missing side squared. I'll write that as L, but you can pick whatever letter you want for that. So this means that L is going to be the square root of 36 plus 144. And this is something you are allowed to plug into the calculator. So square root of 180 then, let's do that on the calculator. So plugging this in the way I've written it here, that comes out to about 13.4. And that's feet, so that's going to be choice C. For this problem, we have a linear function with some table values, and a student graphs the line representing this on a coordinate plane. We want to pick true or false for statements about that line that just got graphed. So we're talking about, first off, whether the slope is positive and whether the y-intercept is positive. Let's deal with the slope first. So taking a look at this, I see that as I increase my x values, I'm decreasing my f of x values. So that slope should be negative. In general, you could write 206 minus 223 over 4 minus 2. But you'll see if you do this that this ends up giving you a slope that is less than 0. That's negative. So in answer to the first question, slope of the line is positive. Well, clearly it is not, so that's false. How about the next one now? Y-intercept. So the key on this one is recognizing that your function is decreasing as you move to the right. The y-intercept, that's the place where x equals 0. That's f of 0. F of 0 is 2 to the left of this table value right here. So if your y values are going down as you move to the right, that means they must be going up as you move to the left. We can say then that the y-intercept, which is just really f of 0, that's going to be greater than 223, because as you move to the left, your numbers are actually getting bigger. Now, the important piece here is that if it's bigger than 223, it's bigger than 0. it's positive. So an answer to, is the y-intercept positive? Yes, it is. That is a true statement. For part B of this problem, a student graphed a linear function as shown here. We basically just want the equation of this linear function, for which we need the slope and the y-intercept. To get the slope, let's just do rise over run. So y2 minus y1 over x2 minus x1. That's going to be 0 minus 228 over 38 minus 0. So negative 228 over 38 is going to come out to, let's do that on the calculator. There we are. That's going to come out to negative 6. Oh, nice whole number. Sweet. So there we go, negative 6. And now this number here is the y-intercept. Now they were very nice to us because they gave us the point at which x equals 0, where this touches the y-axis. The y-intercept is just the y value of that point, so 228. For this problem, we have a student with 2 part-time jobs, babysitting and tutoring, earning an hourly wage at each job, and here's some information. We want to know a system of equations that can be used to find x, the student's hourly wage for babysitting, and y, the student's hourly wage for tutoring. So you didn't even have to solve these equations, you just had to set them up. So x is hours babysitting, y is, or actually x is the wage for babysitting, y is the wage for tutoring. There we go. So first piece of information, on Monday, student earned a total of $130 for 4 hours babysitting and 2 hours of tutoring. That means that 4 times the price of babysitting, which they said was x, plus 2 hours times the price of tutoring, which they said was y, so plus 2y, that has to all add up to $130. So equals 130. All right, doing the same thing for this Tuesday information here. We have 3 hours babysitting, so that's 3x. 1 hour tutoring, that's plus 1y, and that should total $80. So do we have this as an answer choice? It's not A. Is it B? Nope, not quite. Let's see here. C, no, not quite. 4x plus 3y. D, we have 4x plus 2y equals 130. 3x plus y equals 80. It is choice D. For this problem, we want to know which transformation would carry figure R onto itself. So essentially, which of these would not actually change what R looked like? Okay, so reflection over the line y equals 1. Let's look at that. Well, if we flip it over the line y equals 1, then this point here is going to come down here, and that's going to make stuff look different. So it's not choice A. Choice B, reflection over x equals 1. That's reflecting over this vertical line here. That would bring this point over here, which again would make things look different. 90 degrees clockwise rotation, about 1, 1. So that would bring this point over here somewhere, which is going to look different. So that, by elimination, that leaves choice D, 180 clockwise rotation around 1, 1. So basically, if we spin this thing 180 degrees around this 1, 1 point, what happens? Well, since this actually has rotational symmetry about this point, that means that choice D would actually give you an image that looked the same. It wouldn't necessarily be the same image, but because of the symmetry, this point up here would end up down here, as all the other points would end up on mirror images of themselves. So choice D then would give us essentially the same figure. For this problem, population of each of 4 towns is predicted to increase or decrease at a constant rate. Here's some equations representing the population predictions for each town. For part A of this question, we want to use the table to figure out whether the population of each town is increasing or decreasing. So for all of these, you just need to figure out the slope and whether it's positive or negative, and that'll tell you everything you need. For example, Pine Hill, we have a slope of negative 20, which is negative. Therefore, Pine Hill's population is decreasing. Rye has a slope of 15, which is positive. That means our population's increasing. Smithfield, slope of, be careful, they switched the order that they wrote things in, slope of 10. That's positive, so we are increasing. And Troy, slope of negative 50. negative, so decreasing. So then it looks like that decreasing towns would be Pine Hill and Troy, while Rye and Smithfield would be increasing. For Part B, they want us to order their towns based on their populations today from least to greatest. So what part of this equation gives us the population today? Well, they said that the equations here tell us the population t years from today. So how many years is it from today? If it's today. Well, if it's today, then you are 0 years from today. So basically, when you plug in 0 for t to each of these equations, it gives you the current population, which is to say it's just giving you the y-intercept. That is the population today, is the y-intercept. So let's just write each of these, and then we'll put them in order. Y-intercept for Pine Hill is going to be this 180. For Rye, we've got 500. It's just whatever isn't going to be zeroed out when you plug in 0 for t. For Smithfield, we've got 950, and for Troy, 600. Putting them in order now, we've got Rye, that's the smallest population with 500. After that, we've got Troy, Pine Hill, and Smithfield. On this problem, we have a shaded part of a circle here. We want the closest to the area of that shaded part. Now we know that the area formula for a whole circle is pi r squared. This is going to be a quarter circle. How do we know that? Well, this right angle, 90 degrees, is a quarter of 360. So the proportions are the same with the area and the angle that sweeps out that area. So we can just write 1/4 pi r squared then as kind of our area formula for this shaded area. So that's going to be 1/4 pi times the radius 10. And if you square that, let's see, that's 100. A quarter of that's 25, so 25 pi. Let me put that in the calculator to see what it equals. So 25 pi on the calculator, and I just did second and this button to get a little pi symbol. That comes out to about 78.5. So that's going to be choice A. For this problem, we've got a line of our students about to draw a line of best fit for a data set here. We want to know which of the following best describes how to draw the line of best fit for the set of data. And this is kind of a funny problem, if you'll forgive the commentary, because you didn't actually need a real table with data. This is just asking in general, how do you draw lines of best fit? So let's look at each of these. Line of best fit should pass through the origin. Nope, that's not what the definition of a line of best fit is. It doesn't have to go through the origin. It doesn't have to go through any particular point. It certainly doesn't need to connect all the data points, and it wouldn't unless all the data points were perfectly linear. Line of best fit should come as close as possible to every data point. That is exactly what a line of best fit does. Line of best fit should contain the points with the highest and lowest y values. Again, we're not specifying which points it has to go through. It just has to come as close as possible to all of them. So choice C then is the definition of a line of best fit.